Hello everyone. So today's problem is minimum deletions. So given a string S, write a program to delete minimum characters from the string so that the resultant string is a palindrome while maintaining the order of the characters. So let's see first what is a palindrome. So if you see, this is the first index, this is the last index, and the character is R and R, which is same. So this is valid till now. This is a palindrome till now. So let's see the other characters. A and its corresponding end index is this. So A and A, it also matches. So it's still a palindrome. So C and C also matches. And this is E. It will point to itself. So it is also valid. So we can say that this is a palindrome. So let's see what do we have to find in this particular question. So you have given this string. I've made a array representation. We don't make an array, but for the explanation, I have written in this format. So let's number it 1, 2. So we'll check this index and the corresponding last index for this. A and A, yes, it does matter. Does it is the same. So go, we'll increase this and we'll decrease this. So E and D, it's not the same. So we skip this. B and B matches, yes. So now the length is AB, this is BA. So it's even. So we can include C. So we can include C. So this is the maximum length of palindrome you can get from this. But we don't have to return that. We have to return how many characters we did not take or how many characters we deleted. As you can see, we did not take E and we did not take D. So the answer is number of them. So this is 2. So we have to return 2. Let's see the second example. G, and where do we have G? We have G here. So now we can not take E because E is after G, but in palindrome we have to check here. For the second, we have to check the second last because this is the last now because we have taken G. So if we don't take G, what will happen? If we take E, we can take this E. Yes. If we take this E, we can take this E. The current palindrome is this. So we have one more character and odd num or at a odd index. So odd index you can take any one character. It doesn't matter what character you take. So let's see if we have a pair of same characters in between this range. So K we don't have, K, S we don't have, F we don't have, O, R and G we don't have any pair. So we can only select one character. So we can either take K with the E, we can either take S, F, O, R, G. So it doesn't matter. The maximum length that we can get is, let's suppose I have taken K, the maximum we got is 5. So the complete length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 is the maximum length and we got this as 5. So it's 8. So we have to return 8 because we did not consider the 8 characters, or you can say deleted 8 characters. So minimum we have deleted 8 characters. So let's see the anti-chain behind it. So let's suppose we have given the first test case and we'll do a dry run of the intuition here and then we'll go for the recursion tree and the dynamic programming code. So let's say we have taken I and J here because as I've explained you, we need a pair to validate if this is a palindrome or not. So we have to take I and J pointer. So as you can see, both are same, A and A. So we can directly increase I and decrease J. Now there is a problem. So both of them are not the same. So what do we have to do? So either we can make this I plus plus, or we can make this J minus minus, or we can either do both. We can do both. We'll increase both plus plus J minus minus. So we are here, right? Currently we are here. We found that this both are not the same. So we either increase this, we either decrease this, or we increase this and decrease this. So suppose that I'm going for the third choice. I'm going for the third choice. I'm increasing as well as I'm decreasing. So we are decreasing, which means we have not included this and we have not included this. So B and B matches. So we directly move I and J. So whenever I is equal to J, we can say that it's a odd length string, and odd length string and one character is always a palindrome. So if you see, we have not considered this and this, so we have to return 2, and indeed that's our correct answer. So let's see the recursion tree for the same. So in the beginning, I will be here, J will be here. So I and J are the same, so we don't have any choice but to move I plus plus and J minus minus. So I will come here and J will decrease, I will increase. So I and J. So now we have three choices. Either we can make I plus plus, or we can make both of them, which means we have to increase this, we have to decrease this, or we can just decrease J minus minus. So if we increase this, let's see what result do we get. If we increase this, again we have choice because B and D doesn't match. So again we have three choices. Because the recursion tree is very large, I was not able to make it completely. For one iteration I have made, I'll explain you that. Let's continue with this. So so suppose I have moved this one. So B and B matches, so we don't have any choice but to move both of them. So I'll increase this. So for this iteration, we ignore this and we ignore this. So answer is 2. So for this particular line which I've written down, so let's go and do that also. So initially I is here, J is here, both are same. We increase this, I comes here, J comes here, and now both are not the same. So the second choice is make both of them increase and decrease at the same time. So we will increase I and will decrease J. So now we have ignored this and we have ignored this. B and B is correct, is same. So we'll increase J I and decrease J. So both are pointing at the same value, which is I is equal to J. So we say that we stop the algorithm here itself. After stopping, we return 0 because we did not remove any character. So if one is the input string, do we have to remove anything? No, because it's already a palindrome. So we return 0. So in this particular case, in B, C, B, where I was here, J was here, we are returning 0. Why? Because do we have to remove any character for this? No, because this is already a palindrome. So we return 0. But here in this case, where I was here and J was there, let's write it down once again. It is E, B, C, B, D. When I was here and J was here. Did we remove any characters? Yes, we did. We moved I and J simultaneously. We moved I here and we moved J here. So we neglected or removed these two characters. So we returned 2. So if for this particular subtree we get 3, for example, I did not go through and check the left subtree, and let's suppose we got an answer 4 from this right subtree, then we have to return the minimum. This is returning 2, this is returning 3, this is returning 4. So finally we have to return the minimum of all the paths. Here 3, 2 and 4. So the minimum is 2. So we have to return 2 as the final answer. And that indeed is our correct answer for this particular test case. So let's go for the recursion approach and we'll see the code as well. So the approach is very easy. We will take 2 pointers where I will point at the 0th index and j will point at the n minus 1th index. In the beginning, it will be at 0 and it will be at n minus 1th index. So if character of I and character of j is same, we don't have any choice but to increase I and to decrease j. But if character of I is not equal to character at j, we have three choices. What were they? Move I to the right, so I plus plus, that is I plus plus, and add 1 to the result. Why? Because we are ignoring only one character, that is ith character. That is why we are going to I plus plus. And the second choice is moving j, decreasing j to the left, and we also add 1 because we are ignoring the character at jth index because we are going to j minus 1. Or the third choice is we move both I and j, that is I plus plus and j minus minus, and we add 2 because we are also skipping the ith character as well as skipping the jth character. So this is the recursion code I and j and string. So I will change, j will change. So if I is greater than or equal to j, we return 0. For greater, it will not uh, be called because when I becomes equal to j only itself, it will return 0. But still, for safety purposes, we write that. So we have to return the minimum of all the paths. So the first path is 1. Why did we write 1? Because we have to add 1 because we skipped one character and we move I plus plus. For last, we decrease j and we add 1 for the result. And when we are moving both I plus plus and j minus minus, we add 2 to the result. So if this only happens when character at I is not equal to character at j. If it's equal, we directly move I plus plus and j minus minus. And after all this computation, whatever is the minimum, we return that. So let's see how we can apply DP. The time complexity for this one will be, as you can see, there are three choices. So in the worst case, there could be 3 power n operations. So which is very, very high. This will 100% give you TLE. So even for, I think, n is equal to 10 only itself, it will give you TLE. So it's a very, very inefficient solution. So let's see how we can apply dynamic programming. The logic will be same for the recursion and dynamic this memoization code will be same. Just we add DP array. First, we'll see what is DP array and what will be the size of it. If you don't get any of this, please, I'll highly recommend you to go and see recursion playlist of any YouTuber or and you see basic dynamic programming and how we can apply DP array or caching in order to solve it in n square this particular question. So here there are two variables I and j. You can see in the function itself I and j is changing, s is not changing. This is an array, so it is not changing. So s is constant, I and j is changing. So hence the size of the DP will be n cross n. Why n cross n? Because I is the index of s. S can be from 0 to n length. So j is also an index, so it can also be from 0 to n. So that's why n into n. N is the size of the string. If you have already solved a particular subproblem, we will directly return the DP of ij. So let's suppose for this particular subcase, we have already solved it and we got an answer 0. And whenever the function calls for, so this is 0, 1, 2, 3, 4, 5, 6. So j is 4 and I is 2. So whenever function calls, I2 j is 4 and string is s, and this is dp. So whenever it calls this function, we see that we have already computed the result, so we don't recompute the result, we directly return 0. So this is why it reduces the time complexity 3 power n to big of n square, which is very good efficiency when you compare to 3 power n. If we did not compute yet, suppose we did not compute it yet, this was not computed, so we have to compute this first and we'll store that computation in the dp array. So let's suppose we have called this function and we got a result as 0. We got a result as 0. So we'll make dp of I is to j, because we are using the dp of ij, I is to j is 4, and we'll assign it to 0. So whenever in further steps function calls for 2 comma 4, I is to j is 4, we directly see if we have already computed it. In this case we have, so we'll directly return 0. So this is the dp. How we'll initialize it? We'll create a dp first of the same length as the string. I can also go from 0 to 1, j can also go from 0 to 1, and we fill the dp array with -1, because if we don't save the dp with -1, the dp in Java, if you initialize any array, it will hold a value of 0. Initially it will hold the value of 0. So we, for this particular test case, if you see the answer is 0, but it's already initialized with 0. So whenever this function calls, it will check whether we have solved for this particular test case 2 comma 4. It will say yes we have, but we did not. So for that case we initialize array with -1. So we initialize array with -1. So we'll check if the dp of ij is not equal to -1. So let's suppose this was the dp array after initialization, and let's suppose we have calculated the dp of 2 4, and we are saving it here. So it will become -1 0 -1 -1. So whenever next time the function calls for 2 comma 4, we'll directly see this index. So we'll see yes, this is not -1. It means that we have already calculated it. So we'll directly return whatever value is here. So it's 0 here, so it will return 0. So this is the condition where we'll check whether we have already computed it. If yes, we'll return. Otherwise, we have to compute it. And before returning, we will store that particular result in a dp of ij. So this is the complete recursion as well as the dynamic programming code. The link to the nodes and code will be provided in the description. Have a look, and please, if you have any suggestion, comment it down. I'll read and try to improve. Thank you.